Okay, and welcome to the first content-oriented lecture in graphics and animation. And today we're going to talk about 3D space itself and the importance of understanding it. And the reason why we're doing this is because you are literally trained not to understand this. Because everything that you have ever done in art and graphics before this point has probably been two-dimensional. You're thinking in terms of squares, rectangles, and triangles, all of which don't really exist in the three-dimensional world. There's no such thing in the 3D world as a square. It's either going to be a cube or a box or something like that, but it wouldn't be a square. And so the other thing is, you are looking right now most likely at a two-dimensional screen, and you are seeing a two-dimensional representation of me. And so whatever is behind there, you can't see that. There's no way you can. And if something is behind something else, you can't see it. You can't see the side, which is okay under the circumstances. But if you're going to make 3D graphics, you have to have the ability to go beyond that. Okay, so dimensions and space. So first of all, space requires the ability to move or to move things around. And this is kind of esoteric, I know, but we're just understanding what space is. If you're working in space, you want to think of that as the ability to move in one direction or another. And a direction basically implies a dimension, which we'll get into. Okay, movement and location can be measured. Now, when you're doing computer graphics, that becomes extremely important. Everywhere you go is measured in terms of where you are in each of the dimensions you are measuring. So, for example, if you put something here, and you're measuring that from the center of the screen, it'd be something like that, but it would also be in this dimension and this dimension. And so all of those things, they can be measured exactly. So if you have coordinates in the x and y axis of a particular dimension, then you know where that is. And then combining that together, you get its position in three-dimensional space. And as we'll see, when you add the time element, then you get four-dimensional space, which becomes a little bit of an issue. Okay, dimensions determine possible directions. And so if you limit the number of dimensions you're working with, it becomes a lot easier, but at a certain point it also becomes meaningless. So we actually are more used to two dimensions, as I mentioned. Much of what we see is in a two-dimensional context. And let's start with zero dimensions. If you got zero dimensions, what does that even mean? Now, because technically it exists. A zero-dimensional object is either unlimited or infinitely limited, depending on how you're looking at it. So, the way it's best described is a two-dimensional object would be a point in space. A point in space that could hypothetically be in any possible dimension. But it doesn't really matter which it is because it can't go anywhere, because either it's its own universe in itself, and so it thinks of itself as infinite, or it is completely powerless to move in any direction. So a single point in any system is meaningless. That's just the way it is. It's kind of like a 1 or a 0 in terms of binary code. It doesn't mean anything in itself. It's only in context. With no dimensions, there is basically nowhere to go. And with at least one other point, direction is non-existent. And so zero-dimensional objects, we're not really going to do much with them. Now, a one-dimensional object is a line, because that's all it can be. And a line is a one-dimensional creation that connects 2 points somewhere. And so two of these zero-dimensional objects form a line. So you can think of a line as like a railroad track. And so you got starting from Boston going to Chicago, let's say, and anywhere from that beginning to that end can be measured. And so if you are on that line, you have that much freedom. You have that much distance that you can travel. And if you're somewhere in between, that has an expression. You can create another point in that place, which becomes a coordinate. Okay, connecting 2 points, as we said, movement only possible in one direction, either way. Lines are meaningless in themselves, too, most of the time. You can make three-dimensional objects out of lines, but in themselves, there's no such thing as a line. If you've got a pencil, that's not a line, that's a cylinder. And so lines are only parts of other things. And one-dimensional objects are made up of points. And so as you see, as we go up, they sort of build on each other. You can't really have a line without points because it would have no definition. 2 dimensions basically creates what we call a plane. So a flat object, like let's pretend that a piece of paper is flat. So a plane would basically be a flat object, even though it's not entirely flat, there's still some width there. But a plane would be a 2-dimensional surface. 2-dimensional objects have length and width. And so if you're looking at your screen, you got your up and down in this case, which could be width, and your horizontal component, which would be width and length. And so basically a 2-dimensional object has those characteristics but does not have height. Now we usually call these polygons. And like I said, you can't really have a square or a rectangle in the real world as a square and a rectangle because 2-dimensional objects don't really exist. And so we have to interpret them to make them work. For example, if you look at a road map and you see a bunch of squiggly lines, you interpret that as actual places. You interpret that as routes from one city to another or neighborhoods and things like that. But they're not. You know, they're pictures, they're drawings. They only exist on the piece of paper and until you put them in some kind of context using a completely different understanding. Okay, all pictures and almost all art is expressed in 2 dimensions. You know, the great artists, most of them, you know, except of course for the sculptors, you know, they worked in paint, acrylic, and things like that, and they used shadow and highlight to mimic the 3D world. But as long as they're painting on a 2D surface, they're still 2-dimensional. Now, 2-dimensional objects are made up of points and lines. So, for example, a square would be made up of 4 points. A triangle would be made up of 3 points. A square could also be described as being made up of 4 lines, depending on how you look at it, but that's basically it. And so that's 2-dimensional objects. Don't get caught in the 2D trap. I'm just going to warn you ahead of time. I have seen great designers in this course have problems not getting their mind around 3 dimensions. Only because 2 dimensions are easier to deal with. We're used to them. We're used to painting pictures. We're used to drawing things on pieces of paper. The moment you start working in 3 dimensions, you've got to think a little bit bigger. So you've got left and right, up and down, but you've also got backwards and forwards. And you're positioning points here, but you're also positioning them maybe back here. And you have to be able to make those interpretations and see what's going on. And I will admit that is not easy. We'll talk about that today. Okay, 3 dimensions should be relatively easy to understand. That's reality. That's what we're used to. The world we know has 3 dimensions. A 3-dimensional object has length, width, and height. And so basically any object you can imagine, like this, for example, this is tall if it's up this way. It's got width, and it's got depth at the same time. And so we can see this as something that has dimensions. You can turn it around, see it from different angles. 3-dimensional objects are made up of points, lines, and planes. Now that's something that's a little bit sticky to understand. Let's say you've got a cube or a die, you know, something that you roll the dice, a cube, let's say. That cube, in its essence, is made up of 6 squares. Remember how a square is made up of 4 lines? A cube is made up of 6 squares, meaning that each face of that die is a plane. And the planes are connected at 90-degree angles. And here's where it gets a little bit tricky. The inside of the cube does not really exist. Not until you make it exist. And so if you have a 3-dimensional graphics program and you're working with a 3-dimensional object, the inside of that object doesn't really exist. We can't get in there unless we build something there. And so that can be an issue with the program, which we'll talk about later. Okay, 4 dimensions. This is one of those things where we kind of go off the rails here. The 4th dimension in this context is time, and that's really the only context we can work with it. Time and duration apply to 3D animation. So if you have your model car driving across the screen, then there's a point at which it starts, there's a point at which it goes, and there's a point at which it leaves the screen. But that's duration, so the object itself can be said to have that fourth dimension in the context of animation. Time becomes the means of defining movement within 3 dimensions. Dimensions beyond this point are useful, are less useful to us, but they exist in theory. So, for example, if you watch the video that comes immediately after this lecture, you will have this wonderful experience of talking about the 9th and 10th dimensions. And I do suggest you watch it only for your own interest. But I don't expect you to remember any of that, nor do I, it won't be on a test, for example. But it will help you understand what I'm saying here. It'll express that in a nice graphical way. But if you can get beyond 4 dimensions in that video, you're pretty smart. So just bear that in mind. Okay, axes. And I'm gonna admit, I'm not sure if that's spelled right. It's A-X-I-S for axis and axes. I think it is. I'm going to pretend it is. The 3-dimensional world is made up of 3 axes. The x-axis is the horizontal one. Now, these are arbitrary, but it's important to understand that, yeah, they're defined. You can define them any way. You can put Greek letters on them if you want, as long as you know what you're talking about. But traditionally, the x-axis is that one. Then the y-axis is your vertical axis. And so, right there, if you got something positioned within a screen, you got there and there, let's say, those 2 points. And so each of those would have coordinates from the left side or the center of the screen. So if you're going to put the center of the screen as one of your coordinates, that's so far from that in terms of the x-axis and the y-axis. Now, the moment you go for the z-axis, that is in and out. That is that axis. And so if you were 3D glasses, I'd be poking your eye out there. But the idea is the z-axis comes in and out. It's closer and further away to you. So therefore, you can have a point here and a point here and maybe move them around on the different axes. And then you've got all kinds of room for movement. And so that is how that is defined. And with these defined, all motion and characteristics of 3D objects becomes possible. Now, there's imperfections in the way the program works. Now, part of this is that we're asking the computer to do a lot of things. We're asking for the computer to both create 3-dimensional space and movement within a 2-dimensional screen, which is what you're using to create the objects. But we're also asking it to understand this universe in itself, which the computer really doesn't know. The computer doesn't know what gravity is. The computer doesn't know what wind is or what light is. It's just taking our word for it. And so every once in a while, we get off on a tangent. So for example, let's say you've got a 3-dimensional object made up of 2D planes, because that's really the only way it can be done. Each of those 2D planes only has one side. Which is weird, which is something we're not going to understand because the good news is it works because there is no such thing as a 2D object. And so a 2D plane within a 3D object only has to have one side. The other side doesn't have to exist. Now, that saves on space because the computer doesn't have to think about that. And so as long as you're looking at the object, you can see it. But if you were to get inside the object somehow, you wouldn't see anything because there would be nothing to see. It would be a whole other universe, kind of like the TARDIS in Doctor Who. Okay, so if you look at it that way, it becomes rather interesting. So, program is not perfect. Impossible geometry occurs when planes don't intersect properly. If you try to bend an object made up of 2-dimensional planes, usually it will work, but occasionally you go too far and some plane gets flipped in such a way that you see a hole into nothingness. And so that's something you want to try to avoid if you can. Planes do not have 2 sides unless specified. We mentioned that. Objects don't automatically have substance or weight, meaning that if you make something that looks like a tennis ball, that doesn't mean it's going to bounce unless you decide you want it to. Also, if you throw a tennis ball without establishing any of these things, It's just going to go through any other objects you happen to see in there because it isn't going to have any substance. And so those are things that have to be programmed in separately. It's very easy to accidentally move a point in the wrong dimension. And that is true based on the software, because the software is giving you lines and planes in all three axes that it can see. But you're also given another window which allows you to see the totality, which you can move around. And that is in another lecture, which I will put up here this week as well. And it's important to understand the 3D editing windows that come with the modeler program. And so what you're going to want to do is see the next tutorial, which will be listed, which will demonstrate how to begin working on three-dimensional objects. And so next week, after we've settled in, the next assignment is going to be to actually create a three-dimensional object using the program, and ultimately to understand the workflow and submit it to me as a finished object.